GCC hello.c-o hello is really 4 programs in a trench coat. There is a preprocessor, a compiler, an assembler, and a linker, and each one hands its output to the next. Normally they all run in a single command, using temporary files that are deleted before you ever see them. But each stage can be stopped at, and each has a flag. "E stops after preprocessing, "S stops after compiling to assembly, "C stops after assembling. In this lesson and the next we are going to run all 4 separately and look at what comes out of each one, because doing that once demystifies most of the errors you will meet for the rest of your career. When somebody tells you that undefined reference is a linker error, that sentence is only useful if you know what the linker is. Stage 1. "E says stop after preprocessing. Run it, then count the lines in the result. Around 800 lines, from a file that you wrote 7 lines of. Where did the rest come from? 4 things happened. The interlude of stdio.h was replaced with the entire text of that header, and everything that header itself includes. Any macros were expanded. All comments were stripped. The compiler never sees a single one of them. And conditional compilation was resolved, so the #if and #ifdef blocks that did not apply to your system have simply gone. Open hello.i and scroll to the bottom, and you will find your own main, completely unchanged, sitting underneath hundreds of declarations. One of those hundreds of declarations is this line, and it is the reason the whole exercise is worth doing. That is the declaration your call to printf is checked against. Extern int printf, taking a const char pointer called format, and then 3 dots, meaning any number of further arguments of any type. When the compiler complains that you passed the wrong thing to printf, this is the line it is comparing you to. And here is the thing to take away about the preprocessor generally: it is a pure text substitution engine. It knows nothing whatsoever about C. Not the syntax, not types, not scope. It is find and replace with a few extra features. That is why it is so powerful, and it is also precisely why macros are dangerous and why Chapter 16 spends real time on the traps. Stage 2. "S stops after generating assembly, and on x86-64 Linux, hello.s looks roughly like this. You do not need to write assembly, and I am not going to teach it here. But 3 things on this slide are worth noticing. First, your string lives in a section called .ro data, read-only data. That is why modifying a string literal crashes your program, which is a lesson Chapter 11 returns to with feeling. Second, and this surprises everybody, printf has become puts. The optimizer recognized a format string with no conversions in it that ends in a new line, and substituted the cheaper function. Compilers are allowed to do that for standard library functions whose behavior they know. Third, move long $0 into EOX is your return 0. The return value goes into the EOX register by convention. Being able to read a little assembly is a genuine superpower when you are debugging something strange. If you want it more readable, try GCC-S-O2-M-SM equals Intel.